Hello to this video. I'm going to introduce to you the laws of logarithms, and this is related a little bit, and I'm doing this video myself because I want to make some connections with some of the basic ideas of what we've already discussed related with the idea of proof. Now, it's not that big a deal. I just want to throw it there and just have it something that we keep thinking about, keep talking about, and I'm very interested to hear your input. Remember, we talked about the idea of proof if we try to prove something like 4 to the power of 0 is equal to 1. And we saw that proof, and you thought like, okay, that proof was not that hard. And then we looked at the proof of y, for example, minus 2 multiplied times minus 3 is equal to plus 6. Why is it that two negatives multiplied together gives me positive? And we talked a little bit about that proof. So I'm actually going to introduce to you today this thing we call the laws of logarithms. And the laws of logarithms are just a bunch of little rules. Very similar, for example, let me see if I can delete this. Please be patient with me. Almost done, almost done, almost done. Yes, bear with me for a second. There you go. So these are very similar to rules, for example, such as x to the power of a number a times x to the power of a number b is the same thing as x to the power of a plus b. Do you remember we saw, for example, how x to the power of 2 times x to the power of 3 is equal to x to the power of 5. And similarly, we saw how if I have that x to the power of 3 divided by x to the power of 2, in this case I would subtract 3 minus 2 is equal to 1, which is the same thing as simply x. And we went a little bit through some of these in our prior knowledge revision. And laws of logarithms are tremendously similar to this, because if you think about it, a logarithm is kind of just a power, but the other way around. It's a very similar expression with more letters, log. Why would they do that? But of course, it's going to be a very similar rule to this one and to the one we've applied here when we do with logarithms. So let's take a look at those rules. Here they are. These are the rules exactly as they appear in your formula booklet. Let me give you some examples of what they mean. For example, we start with the first one here. If we start with the first one here, what we're going to have, let me change this, here you go. What this means is that if I have, for example, log base 2 of 3 plus log base 2 of 4, this is the same thing as log base 2. Note that the base is always C here, so the base is always going to be 2 on the top. And what do I do? Well, what you do is you multiply the numbers. So what you're going to get? You're going to get 3 times 4. The same thing, therefore, as log base 2 of 12. There you go. Here you have one example of using one of the laws of logarithms. I can do another example with this one here. Very similar thing. If I have, for example, log base 2 of 4 minus log base 2 of, let's say, 1 is the same thing as log base 2 of 4 divided by 1, or simply log base 2 of 4. Not a very good example maybe, but you get the gist. This one's kind of tricky. I'm going to do it over here on the side. What this means is that if I have, for example, log base 3 of, let's say, 4 to the power of 2, this 2 that is to the power of, I can move it to the front of the logarithm. There you go. Notice how all I do is I pick up this 2 and I just move it in front. And now here it is, multiplying rather than being inside the logarithm as an exponent. And finally, the change of base rule. This, by the way, is one of the ones that you use less commonly maybe, but still is in your formula booklet and you may still be in need to use it. Let me fix this forward, sorry. So here's an example of it. What if I have, let's say, log base 2 of 20, and I don't want that. I don't want it to be base 20, I want to change it to base 10. So I could do it like this, log base 10 of 20 divided by log base 10 of 2. So I take out whatever base I want to include. In this case, I've decided it's going to be 10. And I first put the 20 on the top, and then I put the 2 at the bottom, which allows me to change any base of any logarithm to whichever way I want. These are the basic laws of logarithms. Up to this point, this is just what they mean and how we use them. Now, I want you to have a basic idea of how you apply them. The formulas themselves, you don't need to memorize them. They're in the formula booklet. You're always going to have them with you. You just need to apply them. So whenever you find something with logarithms around, just think and remember, hey, I have this formula booklet here. There's plenty of little tricks, little formulas that might be helpful over here. We're going to be working on applying these and being a little bit agile with them. But I don't want to throw things at you without explaining to you why it is. Why is it that these formulas exist? Why do we have them? Why do we have this and this and this and this? So I'm going to give you a proof for them. You do not need to memorize them or learn them, but I do want to make this connection about what is it to have mathematical proof. Here we go. Here's an example. Let's prove this one over here. Now, in order to prove this one over here, I need to start off making some basic definition. And I'm going to say, you know what, what if I start off by saying, let me think about this, how am I going to do this? I'm going to start off by saying that a number m, or let's just say x, I'm going to say that x is equal to log base c of a. And that, on the other hand, I'm going to have that y is equal to log base c of b. I'm just renaming things. Now, if this is the case, this implies automatically, by the definition of what a logarithm is, that c to the power of x is equal to a. And similarly, that c to the power of y is equal to b. Which of course means that if I want to calculate what a times b is equal, it's going to be equal to c to the power of x times c to the power of y, which is the same thing as c to the power of x plus y. Now, what I have here is therefore the following statement. Just taking this side and this side, since this is equal to this, which is equal to this, I therefore obtain that, let me write it over here, this is important, a times b is the same thing as c to the power of x plus y. Now, if I use my definition of logarithm on this expression, what do I end up with? I end up with log base c of ab is equal to x plus y. But of course, if I substitute my initial definitions, what do I obtain? I'm going to obtain that therefore log base c of ab is equal to log base c of a plus log base c of b. Now that would be a proof for this law of logarithm. How do you find it? Do you find it satisfying? Do you think that this is okay? Tell me, just to what extent, on a scale from 1 to 10, where are you in terms of how okay you are with this? And what are some of the axioms that you can identify here? Are you okay with those axioms? Are you think that this is magic, or can you see the mathematical logic behind it? I think that's enough for today. Thank you very much for watching. I'll see you in class. Bye.